Okay, today at River Flow International by Teacher Navasa, we are going to look at this item. An irregular object was lowered into an overflow can A containing water. So the water it displaced was collected in a container B. So as shown below. So we can see this is container B, this is A, which is the overflow can. This is the overflow can. Sometimes we call it eureka, a eureka can. So this is the hand of a person. This is a string. Sometimes when we are teaching, we tell learners that it can also be called a thread. This is an irregular object. This is an irregular object. We have this container and it has measures. So we can measures, I mean this graduation here. This one will be our measuring cylinder, and of course this one they have told us it's water. Let's first perform this experiment and see how it works. So this is our experiment. Our irregular object, in this case we are going to use a stone, which I have already tied on a thread. Then we are also going to use a measuring cylinder. This measuring cylinder is the one which is going to collect the water which will be dispersed. And this one is an overflow can or a eureka can. You can easily relate. You see this spout? This spout here is this thing here, this spout. Then we are also going to have some water which I have put in this measuring. So since we have already tied the thread, we are going to first pour water in the overflow can until it overflows. So you add more water here like this until it overflows. As you can see, water has now started overflowing, which means this is the excess water that is moving above the spout level. Now, once water has stopped flowing, then we come and bring our measuring cylinder here. And then after bringing a measuring cylinder close, then we actually have our irregular object. And we gently lower it into the overflow can. So I'm lowering the irregular object into the overflow can. And you have seen water going out. You can see it is still dripping slowly. So now, the water they are talking about now, this water here that has been dispersed, it is this water which is in this container, which is our measuring cylinder. Now we want to look at some of the questions they are asking. What is the volume of the irregular object? Now, Archimedes says that the amount of water dispersed is equivalent to its volume. So in other words, in the experiment, the amount of water which was dispersed by an irregular object will be our what? Will be our volume of the irregular object. And according to this level, we can see that water is at level 20. So we'll come and say it's 20 and the units is cc. It is given in an experiment. So there is nothing to think about here. Now, part B, calculate the density of the irregular object if its mass is 60. Now, when you are going to answer a question like this, what do they want us? They want us to calculate the density. What else have they given us? They have given us mass. So we know that the density is equal. It is the ratio of mass to volume. Now, anyone who studied some science and some physics knows that this is the formula of calculating density. So we are looking for density. So most of you use density like this as that formula. So M is mass, V is volume. We have mass, which is 60. 60 what? 60 grams. Divided by That is the density. Density equals 60, which is mass. And then, what is the volume? It is 20 cc. 20 cc. When you divide this, you know this one will go like this. This will be 3. This will be 1. And therefore, the density will equal to 3. Now we are going to get other units, grams per cubic centimeter. This becomes our density of this irregular object. Then we come to the principle. What principle is used in this experiment? Yeah, let's tell us what made it possible to happen. This principle is a principle of water displacement. The principle of water displacement. I know physics learners are saying, I can call it Archimedes principle. Archimedes principle. I believe the learners who are already studying physics will have used this. Me as a teacher, I think I have no problem with it. But I would prefer more you talk about the principle of water displacement. But as we know very well, this is a principle by Archimedes. Suggest one method of finding the volume of a regular object. Now, this was an irregular object. What if I want to find the volume of this regular object? What do I use? Number one, I can say by measuring dimensions, using a ruler, for example, using a ruler and calculating using a formula. And most of us know the formula of finding the volume of a regular. If you are looking for area, you will say length times width. If you are looking for volume, then we add height. Length times width times height. So after measuring length, width, and height, I apply this formula to be able to get the volume of regular objects. If you have any issues, if you feel like adding something on this number, please drop it in the comment section. Thank you very much.